Well, we have another question here, question 3. The question says, in the diagram below, P, Q, and R are the vertices of the triangle, and PRQ is equal to theta. The x-intercept of PQ and PR are M and N respectively. The equation of the sides PR and QR are y equal to negative x plus 2 and y equal x plus 3y equal to plus 6 equal to 0 respectively. T is a point on the y-axis as shown on the x-axis as shown. Now we are going to start reading the questions and answer the questions. Question 3.1 says determine the gradients of QP. Well, I'm gonna write here question 3.1. We are looking for the gradients of QP. Okay. On the right here, we're looking for MQP. Okay, the gradients of QP. We do know by definition that's from the formula that the gradient is the change of the gradients. By definition, the gradient is equal to the change of y over the change of x. Okay, so it's like y2 minus y1 over x2 minus x1. Now we're going to write over here that's MQP will be equal to, then I'm gonna look at the points QP are this point, okay, and that's Q and that P. Now this is the x coordinates. I can call it x2, it doesn't matter which one, but I prefer to take this one for x2 and then that y2, and then this is x1 and then y1. Now I cannot take x1 here and then y2 there. If this is the first point, it must be x1 and y1, and then it's the second point, x2 and y2. Now the gradients will be then x1, I mean y2, which is 1 minus y1. y1 is negative 2, so it's going to be 1 minus 2 all over x2 is given by 1, and then x1 is 0, so sub 0 there. And if you work this out, we'll get negative 3 over, excuse me, positive 3 over 1, because 1 minus 2 is positive 3. So therefore, the gradient MQP is just equal to 3. So this is the gradient. Now, that was question 3.1. Now we're going to do question 3.2. The question says that prove that PQR is equal to 90 degrees. Well, two straight lines forms an angle of 90 degrees if they are perpendicular to each other. Okay, that's I'm gonna write the question here 3.2. And then we know that two lines are perpendiculars, okay, are 90 forms an angle of 90 degrees. It means that, so I'm gonna write here PQR equal to 90 degrees implies that PQ is perpendicular to QR, okay? And then two lines are perpendicular if the gradients are equal to, if the product of the gradients equals to -1. So for the first line PQ, over here we find the gradients already, okay? MQR, which is PQ, excuse me, QP, which is PQ, we find that was equal to 3, okay, in the previous question. Now in the line, that's from the line PQ, from the line PQ. Now from the line QR, the equation, the line is given x plus 3y plus 6 is equal to 0. I'm gonna write the question here. We have the line x plus 3y plus 6 is equal to 0. Okay, here we need to be careful because usually we know that the gradient is the coefficient of the x of the term with x. Okay, quickly someone may say the gradient here is 1. Some other even say it's 0. Okay, it's not 1, it's not 0. First, we need to write, okay, this equation in the gradient intercept form. The gradient intercept form is this form, y equal to mx plus c, the well-known formula. Okay, now we need to rewrite the equation that we see in that form. Okay, now I'm gonna move x and 6 over, so this will be 3y equal to negative x plus 6. Now I will divide the equation by 3 because I need to get the form in the previous line. So I divide each term here by 3, each term by 3. So this will make y equal to, that makes negative 1 over 3 x plus 2. Okay, so now then we can say, okay, the gradient is negative 1 over 3. So therefore, I'll say therefore, the gradient MQR, okay, is equal to negative 1 over 3. I'll move my board a little bit there. So now let's see. We said that two lines are perpendicular if the product of the gradient equal to negative 3. So if implies here M1, which is MPQ. Okay, M1 times MQ, M2 will be equal to negative 1. I have to move, will be equal to negative 1. M2 will be equal to negative. That's the condition. Okay, so in other words, we're gonna do we're going to check that MQP times MQR. We check if this equal to negative 1. Okay, if we substitute the values of MQ, we see that MQ is equal to positive 3. Okay, and then this MQR equal to negative 1 over 3. Yes, this is equal to negative 1 because we got like negative 1 equals to negative 1. This is proven. Therefore, we can say therefore the angle PQR equal to 90 degrees. Proven. Okay. Now the following question is question 3.3. The question says, let me just highlight here. The question says, determine the coordinates of R. Okay. If you look at the graph, the coordinate of R is actually, this is the point, okay, the coordinate of R. Now I'm gonna move my board over here. Just split my board a little bit like this. Okay, and then maybe it's important for me to place here the same graph. I'm gonna put it here. Okay, here's the graph. Well, we need to find the coordinate of this point here. The point R. Okay, so we know that the point R has like the two coordinates x and y. I can call it xr and yr. Okay, so we notice that this point R here is at the intersection of the two lines, the lines QR and PR. So at the intersection, it means it's where the two lines meet. In other words, when the two lines are equal, the equations are equal. Okay, so we are going to equate the line, like, because there are like two equations, something like working out the two equations simultaneously. Okay, one is given by y equal to negative x plus 2, and the other, remember we did write it in the forms of y in the previous equation. It was given by y equal to negative 1 over 3 x plus 2. So now this is like equation 1 and that equation 2. Then we can solve, because the two y's, we can just equate the equations. We're going to make, or maybe just take the value, this value, substitute it over here, because that's negative x plus 2. Excuse me. So this makes negative x plus 2 equals to negative 1 over 3x plus 2. Then I can move the negative 3x over. Okay, we have like negative x, excuse me, negative x plus 1 over 3x. Okay, and then I can move the 2 on the other side. So I moved negative 1 over 3x over, and then moved the 2 on the other side. Then this will be equal to 2 minus 2. Okay. Then oh, excuse me. I think yeah. I wrote this wrong. This is -2. Sorry, that was -2 there, because when we move the 6 on the other side, let's see. I think. Oh, I meant to write -6 here. So yeah, -6 and -2. Correct. Then there were -2 there. Then if you work this out, a negative x plus 1/3x, okay, it's like you can combine this, because the two here they're all expressed in terms of x. Okay, the like terms is like you have like a -1 here in front of x. Okay, I can see that the answer will be -2/3x, but let's just work it out, the fraction. I'm gonna times the whole equation by 3. I'm gonna times everything here by 3, and there also by 3. Okay, just to cancel the fraction, that will make -3x plus x equal to -12. Okay, and then this will make -2x equal to -12, and then we can divide the equation by, we can divide both sides by -2. Okay, we divide by -2, and then what you get, x is equal to +6. Now that you got x, we can substitute in either equation 1 or equation 2 in order to find the corresponding y value. So this will be I prefer to take equation 1. From equation 1, which is given by y equal to -x plus 2. Okay, then I sub in the value of x here. Its value is 6. Sub 6 there, and then get y equal to -6 plus 2. Therefore, y will be equal to -4. So therefore, I say therefore r will be 6 and -4, and that makes more sense because you can see 6 is the x value, which is on this positive side, and then y is the -4, which is on the negative y. So that makes sense. So r equal to 6 -4. Then the following question says, let me move the board like this. So this was now we're going to do questions question 3.4. Okay. The question says, question 3.4 says, calculate the length PR, length of PR, leave your answer in the third form. Well, I'm gonna move my board here, over here. Okay, that was question 3.3. That was 3.3, and now we're doing 3.4, which is the length of PR. So this length we are looking for. I'll show this way. This length, this one, PR. Let's just move my board over here. 3.4. We're looking for PR. Well, by definition, the distance, the length is the distance. We use the distance formula to find the length. Is given by x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2. Okay, so over here we want the distance PR. This will be square root of okay, to the power of 2. X2 is, if I look here, P, the coordinate are 1, 1, and then R, the coordinate are 6, -4. So this will be 1 minus 6, okay, because x2 minus x1 plus that one will be 1 minus 4, okay, and then the distance PR will be equal to 5 squared plus 5 squared. This will make that the distance will be equal to square root of 50. And then square root of 50, you know, we can the calculator can say so if you press in the calculator, we will get something like d equal to 5 roots 2. Let's just use the calculator to show you. Because over here I did this, you know, this is like square root of 25 times 2, right? And then this can be brought down root 25 times root 2, okay? And then root 25 is just 5, and then root 2 is a third. You can do that. Or I think calculators, cash calculators can also do the same thing, because this will be, if you just write root square root of 50, I guess it's going to do that. Yes, it gives like 5 root 2. Then now let's see the following question. Over here, okay, question 3.5 now. Let me move a little bit there. Well, the question says determine the equation of a circle passing through P, Q, and R in the form x minus a to the power of 2 plus y minus b to the power of 2 equal to r squared. All right. Now I am going to I'm gonna move my board over here. Okay. And then okay, I'll move it over here. I think it's also important to put the same diagram. Okay, let me just move it over here, and then well, now I think I'm gonna put the same diagram over here. Okay, this is the graph that we have now. The question says that we need to find the equation of the circle that passes through the following these points P, Q, and R, these 3 points. All right. I just want to remind you that previously we did find that this angle was the angle here was 90 degrees. Okay, we have a right angle triangle here. Then if I can draw a circle, it must be something like this, like something like this. So will be okay. It's not really my circle may not fit. Yeah, it does. Nice. Okay, that's the circle. Then by inspection, you already see that this line here seems to be the diameter. And just because it is the diameter, I'll tell you why. Remember, in Euclidean geometry, you learned that okay, over here I said it was 90 degrees. Over here it forms a 90 degrees angle, and then it is said that the chord subtended 90 degrees center of the circle. Okay. Okay, that's what am I saying here? I was trying to say that the chords, okay, this line here over here is the diameter of the circle. This one, okay, it's the diameter of the circle. This one, because we have like we have a 90 degree angle over here. Okay, then we have like points R. We did find it previously. The point of R was 6 and -4, and then we have the point 1, 1 there. Now we can find over here. Okay, I'm gonna say here PR. Let me move this the board like this. So we have like PR here is PR is the diameter because it's when this chord here subtends 90 degrees. Okay, diameter because okay, original right here chord subtends subtend 90 degrees angle. So PQ is a diameter. Now we need the equation of the circle is given by as the question says, this is given by y x it is given by x minus a to the power of 2, okay, plus y minus b all to the power of 2 equal to r squared. Okay, then I am going to and then what else we know from the equation that a and then b here forms what? The coordinate of the center. So the center of the circle, a and b, okay, and then r is just the radius. This is the radius. All right, now to find the equation of the circle, it means we need to find the coordinate of the center and also the radius. Now that we know the diameter, we know the diameter because the diameter is simply the length PR. We did find it in the previous question, and we did find that this was equal to 5 square root of 2. Okay, and then if I need to find the radius is half the diameter, so the radius will be something like this over 2, 5 over 2 square root of 2. Okay, then the center will be the midpoint of, so the center will be the midpoints P R. So the center of the circle is just the midpoint PR. Then the midpoint is given by the midpoint, okay, is given by x1 plus x2 over 2, and then y1 plus y2 over 2. So about that, just say over 2. Okay, then the center will then be 6 plus 1 over 2. Okay, 6 because the x coordinates here is 6, and then the x coordinate there is 1, and then the y coordinates over here is -4, and the y coordinate over there is 1 all over 2. Then the center of the circle will be equal to 7 over 2, and then -3 over 2. Now, therefore, we can say then the equation of the circle is x plus 7, minus, okay, minus 7 over 2. The minus because, I know it's positive, but minus because of the formula here, x minus a to the power of 2 plus y, careful here, it's, I know b is -3 over 2, but there we have another negative in the formula, so negative of the formula and the negative of this term with b, the negative of b, both makes positive, so that will be positive 3 over 2 to the power of 2 equal to r, which is half the diameter. It's going to be 5 over 2 square root of 2 to the power of 2. Okay, and then this will be x minus 7 over 2 squared plus y plus 3 over 2 to the power of 2. And then if you work this one in the calculator, this will be 50 over 4, but you can check it out. If I say this answer divided by 2, oops, okay, we have like, when I rewrite it here, we have like 5 roots 2, okay, over 2, raised to the power of 2, to the power of 2. Okay, to the power of 2. This is equal to 25 over 2. Okay, 25 over 2. All right. So that's the equation of the circle. Good. The following question is a question 3.6, I guess. Let's see. Yes, 3.6. The question over here says, determine the equation of a tangent to the circle passing through P, Q, and R. All right. Okay. Let's first read it again. It says, determine the equation of the tangent of the circle passing through PQR, okay, at point P in the form y equal to mx plus c. Well, I want to move the board over here. Okay. So this is what you find in the previous question 3.5. Okay, that's the circle passing through the point PQR. Now we want the equation of the tangents, okay, that pass through the point P. Okay, so in this situation, let's just do it over here. Okay, 3.6. So I'll do it over here. Okay. So I prefer to redraw the same diagram so we can see clearly. Okay, this is the diagram we have. Now we know that tangent is a straight line that passes through a point. Okay, so now if I can draw my tangent line passing through, just for sake of illustration, passing through the point P. Okay, tangent to the circle passing through point P. Okay, let's say it is this line. Okay, that's the tangent line. Now, approximately, okay? Now we want the tangent line to, okay, passing through point P to this circle. But what we know is that maybe if I want to be a bit accurate, I need to redraw this tangent line. Okay, just try to be a bit accurate. The line doesn't seem to be, okay. Okay, almost this, like this. Something like that. Et voilà. Now, there are conditions, okay? We must know that the tangent line is always perpendicular to the diameter or to the radius, okay? So that's we know by definition, okay? Tangent to the circle is perpendicular to the diameter. So, okay, we are looking for the equation of the tangent line. The tangent line is a straight line. It is given by the form mx plus c. And then we say that the tangent line will be perpendicular to the diameter or to the radius. So I'm going to say here tangent line must be perpendicular to the radius or to the diameter of the circle. Then this simply means that okay, what is the diameter? What is the equation? Because the diameter here or the radius is also given by this line, y equal to negative x plus 2. Okay, over here we can see that let me just do this. Over here we can see that the gradient here of the line of PR is -1. Okay, then therefore the gradient line of the tangents will be -1. So therefore the gradients of the tangents will be equal to +1, excuse me, because the product must be the product of the two, okay, must be equal to -1. Okay, that's the condition to have perpendicular lines. Now we can write the equation of the gradient y equal to -1x plus c. Now, if I substitute a point P, because this is the point that lies on the tangent line, I can only take that point, the point 1, 1. I'll sub 1 for x and 1 for y, 1 there. This will be equal to 1 equal to -1 times 1 plus c. And then this makes 1 equal to -1 plus this is going to be, oh no, the tangent is positive, the gradient of the tangent is positive, +1 here, yes, +1 plus c. If I move the 1 over, we have like 1 minus 1 equal to, it's equal to 0. Therefore, the equation of the tangent line is just the line 1x plus 0, which is y equal to x. Y equal to x, that's the equation of the tangent line. And then we can see approximately this graph here, the tangent line passes, it's much closer, it passes through 0. When I try to be accurate, you see it fits actually passes through the origin. That's the equation y equal to x. Now, the following question is question 3.7. Let's see. Question 3.7. This one. The question says calculate the angle, the size of the angle theta. Okay. Angle theta is this angle here, as you can see by R there. So now I'm gonna move my board over here so we can see everything clearly. Let's plate it like this. Okay. And then so okay, I think it's just important for me to redraw the same triangle over here. Okay, so I'm gonna put the same diagram over here. Over here. Okay, yes, the diagram. I'm gonna write here like 3.6. Okay, we need to find this angle Q, theta. Excuse me, the angle theta. So what do we know from, how can we determine angle theta? Because we only know that this angle is 90 degrees, but we don't know about this angle, and we don't know about that. Okay, nothing said about, nothing, we have not much information by looking at the triangle only. But we cannot just focus on things inside the triangle here. We can also look everything in general. What else do we have? Maybe I should remove this circle out. Let's take it out. Okay. We can notice that we have this angle. Okay, let's just remove other information. So we have like a 90 degrees angle here. Previously, okay, we can find the angle N and M in order to find the angle P, because why am I saying that? Because we know the gradients of these lines. Okay, we know the gradient of that line. Let's say here that we're looking for theta. So we do know that the gradient can be expressed by tangents of the angle. Okay, so the gradient of this line is -1. Okay, we can see the coefficient of x. It's -1. So I'm gonna say m will be equal to mpq, pr, excuse me, which is -1. We can find tangent. We can find the angle n here. Call it like, no, let's say pnt. Okay, we can find the angle pnt. Okay, this will be tangents of the inverse function. Okay, so we're gonna say we press shift here, then of -1. Okay, and then when we hit equal, that makes -45 degrees. So -145. Okay. I was saying, okay, when we got a negative value like this for angles, we just plus 180 degrees. Okay, we plus 180 degrees, and then we got its value. So we find that this angle is 135 degrees. Now, previously we did find that the gradient of the line PQ was equal to +3. So to find the value of this for this angle, we're gonna do wanna say this one, we found this 135 degrees. So over here we're gonna find the angle PM. Or I call it like that. PMO will be what we're gonna do. We press shift here, and then 10 positive 10 of 3, and then we hit equal, and this is equal to 71.57 degrees. Okay, so this angle here is just 71.57 degrees. I said that because, as I said previously, we did find the gradient here was equal to 3. The gradient of the line PQ was equal to 3, so we got this. Now, there is a property. Okay. If I need to find P, for instance, okay, I can just manipulate these angles. So this is like, if this is 71 degrees, we can see angle in the straight line, okay? Or we can say, I can find these angles, okay, fine. This angle is 45 degrees, and that angle is, will be 90 minus 71.57, okay? 180, that's gonna be minus 180. In other words, if you do 180 minus excuse me, that's not exactly correct, that's wrong. The 71 degrees is not the angle outside the triangle, actually inside the triangle, because the angle is always this one, excuse me, as I did here. So I misplaced the value of the angle over here, so let's just put it in the right place. It's this angle, okay, M. It's this angle over here, that is 71.57. Now, we do know one of the property in the triangle. In this triangle, if I look at this triangle, this part, okay, the external angle is equal to the sum of the two interior angles here. So we have like 71 degrees, 71.57 degrees, plus the angle P, okay, equal to 135 degrees. So if I need to find P, okay, I can just move 130, I can just move 71.57 degrees over, and then this will be equal to, we can do 135 minus 71.57. This is equal to 36 negative 30. Oh, sorry, I missed. I wanted to say 135 minus 71.57. Yes, like that. Press equal, and then we hit. Yeah, this is equal to 63.43 degrees. So 63.43 degrees. 0.43 degrees. That's the angle P. Now that we know this angle P, and then we know this is 90 degrees, we can find angle theta. Okay, therefore, I can say, therefore, P plus Q plus theta equal to 180 degrees. Okay, sum of the angle in the triangle, and then that means that theta will be equal to 180 degrees minus P minus Q. Okay, we sub in the values, 180 minus P, which is 63.43, minus Q, which is 90 degrees. Okay, or we could just do, okay, anyway, theta would be then 180 degrees minus 63.43 minus 90. Okay, this is equal to 26.57 degrees. So it makes 26.57 degrees. Thank you.